Here in Europe, it's midnight, so I'm not quite as fresh as I used to be at conference. But let's start. My name is Michael Staib. I'm a Microsoft MVP, and I'm one of the authors of the Hot Chocolate GraphQL library for .NET. And today I want to talk to you about GraphQL in general, what it is, why you should care about it, and what we can do with it with ASP.NET Core, because I think a lot of you are .NET developers. So what is this GraphQL actually? What can we do with it? Why does it exist? So GraphQL originally was developed by Facebook in order to solve their data fetching issues between their backend and their mobile applications. And let's just head into some GraphQL and explore what it is. So if we look at this simple GraphQL query here, then we basically ask the server for the currently signed in user, and from this currently signed in user for the name. And if we send that to a GraphQL server, we would get a response that closely aligns to our request. It almost is as if the GraphQL server just fills up our request with some data. It is not like that, but it's a good mental picture to start thinking about GraphQL. But as our use cases change over time, we don't have to change our backend. We just can change our requests. For instance, we ask for the profile picture of that user, and we might want to know the width, the height, and the URL of the profile picture. Again, the GraphQL server would respond with some predictable results that closely align our request. And if we look closer at this actually, we can see that GraphQL is not about flat data structures or sparse fields. We can see that it's actually about data trees. And if it's about data trees, we actually can push data aggregation now back to the backend. Like in this example, we are exploring related objects to our user. We are fetching not only our user, we are also fetching the friends of our user. But if we look closely at our request, we can see also some repetitions here, like name and last seen is added 2 times. And if you think about larger GraphQL requests, there would become a problem with copy pasting. So GraphQL has introduced for that something called a fragment. A fragment in GraphQL is a primitive of composition. You can build fragment hierarchies with that, like you can build component hierarchies in your UI components and class hierarchies in your backend. But enough about the theoretical constructs about GraphQL, looking about GraphQL queries. I actually prepared a little exercise to get us all started with GraphQL and understand the problems better. So I hope you all know some Star Wars, because there is an API which is called swappy.co. It's an exemplary REST API that tries to teach some principles of REST. Let me switch over. This Star Wars API has a ton of Star Wars data, like the characters, the planets, the films, and other things. What we want to build now, or the experiment we want to do, is to fetch all the characters, just a list of names of characters that played in movies alongside Luke Skywalker. A simple enough task. So let's first explore our REST API and check how we can do that. So our REST API exposes some resources here, like the people resource. We could do a simple fetch on that. And then we might get a list of characters, like Luke Skywalker, 3CPO, and so on. And if we look at that data, we can already see that each of these entities or characters has its own URI. So we could fetch a specific character instance, like this 3CPO. And this character instance exposes a list of movies. And these movies are represented by a reference. So I can fetch this movie, for instance, and get some data about that Star Wars movie, like the episode ID, the title. And I can see the characters that appeared in that movie. And I could drill in deeper. And with this information, I already kind of know how to create this algorithm to fetch this list of names. And this is the only JavaScript you will see today, but I built up a little benchmarking here. So I built up a little function in JavaScript to fetch the characters that appeared alongside Luke Skywalker in Star Wars movies. For that, I fetched the Luke Skywalker character from the REST API and then iterated over the films array. And then I fetched each of the films. And the films exposed this characters array. So I fetched each of the characters that appeared in that film. And then did some data massaging, extracted the name and built up the list. So let's have a look how that performs. So this is my little benchmark. I pre-ran it just to be sure that it works. It took 2.9 seconds, which is not bad for all the data we had to fetch. So let's run it live and see how it turns out now. We can see that we are aggregating a ton of requests. It's actually the same amount of time here, but we aggregated a ton of requests and fetched a ton of data. So that cannot be very efficient. Let's explore how we would do something with GraphQL. So there is something called GraphQL IDEs. This GraphQL IDE is built by our open source project. It's called Banana Cake Pop. Like we have a lot of special names. And with that, we can explore GraphQL endpoints. I built the Star Wars API for GraphQL, and this Star Wars API actually fetches the data from the same REST service that we used just a few seconds ago. And when I open a GraphQL endpoint in my GraphQL IDE, I can click here on the schema button and explore what the data is about. For instance, I see that my GraphQL endpoint has a query root type and exposes some fields. In this instance, a character field. And if I click on that, I can see that the character returns a character here with some properties like iColor, a movies array that exposes movies. And I could drill into that, see that I can actually look at the movie that the character played in. And I also see that it, again, explores some characters. Okay, so I kind of have the same structure as my REST API. But I also can see that I need to provide an argument, the ID. So let's have a look at how we can build something with that. Let me switch back here. So in GraphQL, we already saw in the initial examples of GraphQL queries, we start with some squiggles. And then we basically define from what we want to fetch some data. For instance, we fetch the character and the character 1, which should be Luke Skywalker. And then we can pick from the properties that we have there. For instance, the name. Now let's just fetch the character. We can see, boom, we get Luke Skywalker. Okay, but actually we want to really get all the movies, and from the movies the characters that played alongside Luke Skywalker. So we fetch the movies, and from the movies we fetch the characters, and from the characters the name. And actually Luke Skywalker's a name we don't need, we just want the names of the characters that played alongside Luke Skywalker. Let's fetch that. 45 milliseconds, the same REST API, but it doesn't have to transfer down to me, and I don't have any cascading requests. And I basically don't have to write any code in JavaScript apart from destructuring here my response structure to get just a list of names. So let's go to our benchmark. Let's just have a look at our developer tools as we did with our REST request. Just run that. 247 milliseconds. So it depends on how fast we get the data from the REST service. And we can see we just have 2 requests. Okay, that's quite awesome. We have multiple times faster request. We don't have a lot of connections. And that's exactly why Facebook developed GraphQL, in order to get rid of the aggregation of data on the client side. Because on mobile applications with a bad connection to the internet, this really matters. And it also matters on my system where I have 1 gigabit internet connection, because it still took 2.9 milliseconds to fetch that data. Okay, with GraphQL, I only have 1 endpoint, because I only need 1 endpoint. Because I, as the consumer, define what requests I want, I craft them, and I send them to the server. And that means I also can fetch all the data that I need at one specific moment in time with 1 request. And this gets really rid of the over and under fetching problem on the client side. Meaning, overfetching is basically when I had to consume all this data from Luke Skywalker, the films, and all the characters that I actually don't need. I just needed the list of names. And underfetching is when I had to fetch another request that is cascading, when I basically built up those cascading request pipelines where each request had to wait for the previous request. And basically my data fetching was unparallelizable. And GraphQL is built on a strong type system. That means if GraphQL tells you that a field is a string, then this field is a string and will never be an int on the client side. And if GraphQL tells you something is never null, it will never be null. And this really lets you write code in a different way on the client side, because you can do assumptions about the data. But apart from that, GraphQL is not only just simple fetch and pushing data to the server, it's also real time. And we will look at that in our examples that we will do in a minute. So we could also do a lot of this with REST. We could build very specific endpoints that fetch everything very efficient for us. But with REST, we always have to work together with our backend engineer. We have to define new resources, new endpoints, which basically gives us the data more efficiently. And we all know that maybe our backend guys have no time. It goes back to their backlog. It slows down the front-end engineers. Also, there's a lot of negotiation between backend and front-end engineer, and there's a lot going wrong with this. So with GraphQL, we don't have that. So what is GraphQL? GraphQL is a query language for your API, and it's a runtime to execute those queries. And GraphQL is really thought from the business layer. So when Facebook started developing that, the backend engineers came together and thought about how they could expose the business layer in a much better way. So GraphQL gives you a much richer way to expose your backend data. But GraphQL is also great as a gateway technology where you bring together all those microservices that you have in the backend and build this ubiquitous data graph, which represents the single source of truth of your business model. So GraphQL reverses the responsibilities and gives the consumer the power to ask exactly for what they want, nothing more. But this also, in turn, frightens some backend developers, because now you basically have the power to drill into arbitrary data of the backend and fetch like you want. And how can we, as a backend developer now, make sure that some requests don't kill our server? So actually, GraphQL is not only a query language, it's also a data definition language. And this is actually a chance for us backend developers to mold our data graph, or mold how the consumer of our API can access our data. How does the front-end engineer really interact with us? What costs do we allow for queries? And how is this front-end developer able to access our data? We can all mold this in a very strong way. Okay, so in GraphQL we have three operation kinds. There's query, we saw that, basically side effect-free fetches of data. Then we have something called mutation, which is the put, post, patch, delete of REST. And it's basically what produces side effects. And then we have something that we don't have in REST. It's called subscription, and it's basically real-time data. You have something like that with WebSockets or SignalR, but on a much lower level. With GraphQL, it's basically as if you were consuming a GraphQL query. And we will see that. Before we get into our demos, let's also talk about what GraphQL is not. GraphQL is not a graph database query language. It, in fact, has nothing to do with databases or any graph databases or databases. Or it also has nothing to do with OData. If you look at OData is more designed like a SQL query. Like you have all those filter methods. It's very close to a database query language, and it was also designed with this mental picture when it started as AtomPop, with its AtomPop format a few years ago. But GraphQL really was designed from the API layer perspective, so it's much richer. GraphQL is not a good solution for binary streams. And Netflix is really using GraphQL, but they're not using it to stream movies. So it's good for structured data. And some misconception is also around that GraphQL is for HTTP, but it's actually transport agnostic. So it works over gRPC, it works over HTTP, it works over WebSockets, about TCP, whatever you want. And one misconception that actually I said in the beginning is not true is that it's not designed for the JavaScript world. Actually, the first GraphQL server was not written in Node. It was written in PHP by Facebook. And also the front-end consuming clients were written in native clients for mobile applications. So it had nothing to do with actually web in this instance or with JavaScript. Okay, let's explore how that actually works. Let's see some code. Let me get rid of this browser here, and then let's head into some code. Okay. So I opened up Visual Studio Code. This is actually an empty project. There's nothing at the moment. So the first thing we do is we create a new solution. Let's call it demo. And the next thing we do is create a new project. Let's create a new web project. And let's call it also demo. And just add it to our solution as an add demo. And now we have a proper web project here. Actually, it's a standard empty ASP.NET Core web application. There's nothing special to it. We have our startup that we know. There's nothing in here. It's just a .NET 5 application. And since we are doing .NET 5, we are using our brand new GraphQL server today. That is still in preview like .NET 5. We will release it alongside .NET 5. So we are doing .NET add package, .NET add package to demo. And it's the hot chocolate ASP.NET Core package in version 11 preview 154. Let's add that. Let's just reload the solution so everything is indexed correctly and go into our startup CS. So every GraphQL server actually starts with a query. A query is what you need for a GraphQL server. If you don't have a query type, you don't have a GraphQL server. Mutations and subscriptions are optional, but you need to have something to query. So a query type actually is represented in .NET as a class query. You can name it differently. You can call it foo, bar, it's up to you. But it is a class, and you need some resolvers on it. Resolvers are the fields that fetch the data for you. So if I write here something like a public string, say hello, and return a string hello, and this is our resolver, and I could query that. But let's make it more exciting. Let's say we have a string here with a name, and we type the name in here, and by default it actually is Michael. Hello, Michael. So let's run that. Oh. Project demo. Okay, let's grab that. So a GraphQL server by default is hosted on the endpoint on GraphQL. And I just can call that actually. I should be. Oh, we forgot something. We created this query type, but we didn't actually create our schema. So the first thing we need to do is actually create our query type, then set up our schema. And this is basically done by using the service collection here, saying add GraphQL server, add query type, and then we add our query type here. And the second thing we need to do is to add something that executes our GraphQL server. So we use the endpoints API and say map GraphQL. And now we repeat what we did. We start our server, go into our Chrome here, and now on GraphQL is our GraphQL IDE, which I get rid of this. And this is basically served up when you go with the browser on this endpoint. We will serve up banana cake pop, so you have something to debug GraphQL IDE. Okay, so I can go now here in my Schema Explorer and see I have a field say hello here. It is a string. It's actually a nullable string, and we will see why that in a bit. And I can now query for this GraphQL field here, say hello, and I get hello, Michael. And I could also see that I can say hello, Sydney. And then I get hello, Sydney here. So the schema builder of Hot Chocolate will inspect what C# code you write and infer from that actually your GraphQL schema. If we look at that, we can already see that it's really the default value that is correctly inferred. But everything here is nullable, and GraphQL has a concept of nullability. And that's why we should also enable nullability in GraphQL. Like we should say nullable enable. Let's reload this code. So it reloads the project file. Let's restart that. Refetch our schema. And we can now see this exclamation mark, and that means this field is non-nullable. So it doesn't allow null. And when I now fire that, it actually executes the same. But if I would provide null here, it already squiggles me here and says, okay, you cannot put null in here. And if I would execute that, it actually allows me null, which is not good. As I said, it's a preview. And I just found a nice bug. That's interesting. Okay. Let's head into the next demo. So we did our first GraphQL server. Awesome. And we also found a bug for our V11 server. I will look at that after the talk. Okay, but this is just a simple example. Like in real life, you would actually use something like maybe entity framework, MongoDB, some database, some proper objects to expose in your GraphQL API. So how would that work actually? How would a GraphQL server develop when we put proper objects in there? So let's get back to our GraphQL server. Nullable has to be enabled to enable nullability compilation. There was a question I don't know if you see if it shouldn't be disabled. So if you enable nullable, it means that the compiler now annotates these reference types in .NET, and now I have nullable reference types. So if nullable is enabled, actually reference types like this become non-nullable reference types. And this would be a nullable version. This means if I run that, I would now, let's refresh that, get a nullable version of the argument here. And actually the execution engine should have raised an issue for me providing null here. But that is, so we have a stable version, 10.5. This version is actually coming out at the end of October. So there are still some bugs, but it also lets me show off some nice .NET 5 features. Okay. So let's put some proper models in here. I have already prepared here some data models, so I'm not boring you with typing. We're putting them in. So it's really a simple data model, some author that has a name and an ID, and an author has some books. And a book has an author and a title and an author ID. So a very simple model. Then we have some DB context, which at the moment screams at me because I didn't have any entity framework reference here. We will fix that in a bit. But it's basically a simple DB context. We will be using SQLite here. And we call that demo. And yeah, it's a basic setup. So let's add some, and I prepared some commands, so I also don't type. This is a new entity framework, actually, what we are using here. Entity framework 5, also preview. And let's add also some data integration here for Hot Chocolate that enables some functionality I will walk you through as we upgrade the whole server. Okay, so we added some packages here. And in order to really run this thing, we need to create a database. And for this, there is some tooling, some local tools for .NET Entity Framework. I will install these. And then we basically run some create some migrations and run them. So we will end up with a database. So it built the project. Now it should, yeah, there's migrations coming here. And now we have a database. Okay, so let's build this server out. So in order to have to put Entity Framework into our server, we first have to get up here and add Entity Framework. Since GraphQL on queries executes in parallel with multiple threads, it's actually not so good for Entity Framework. But Entity Framework 5 allows to use pooled DB contexts that we can rent and return. So each thread that then executes something against an entity context can have its own DB context without producing too much allocations. So this is now called add pooled DB context factory. And let me just grab this guy here. Get rid of this. I just needed that for the database migration generation. And let's put that in here. I'm not an entity framework guy, actually, so I'm not as Let's reload that. Just wait a second. Add pooled. Yes. That actually should work. Let's compile that. What went wrong? Yes. I forgot to specify the DB context that we want to use. So it's books, book context. And then we say import stuff here. Yes. And now it will work. Yeah, import this. And now we are out of the woods. That's as far as I know about Entity Framework, and as far we need for the talk. So the next thing really with a query type, we can head back here. Let's get rid of our simple resolver here and put some proper database logic in here. This could also be some other database technology, as I said. So in this instance, we are using a queryable of maybe book, and we call this get books. And then we need some DB context. So let's put the DB context in here, book context, and maybe just return from the book context the books. And actually, let's do that the same thing for the authors. Get author. And in this instance, we are returning the authors. So this is basically, this is very simple stuff. But I said GraphQL is executing in parallel. So how do we inject this stuff? There is something called a middleware in GraphQL. It's a field middleware, and we can annotate field middlewares onto our resolver methods. So we can say use DB context. Import that. And this is one of the things that I installed basically with the packages that I installed for Hot Chocolate. And now I can just define which book context I want. And then I specify here that this is actually a field scoped context. So it just lives for the execution field scoped service, sorry. And it just lives for the time of the execution of this field. And the same let's do here. And also just steal this attribute, put it here, and let's rerun our server. It should already work. Okay, let's rerun that. Go back here, refetch the schema. We get books. And we can click on that. We can see that we not only have the top level fields, we can really drill in. We have the books collection that we have here. We can see the author, and we could drill in forever. So we didn't do a lot, just 2 lines of code actually, and this entity framework stuff. And we already have quite a populated schema. We just can query this stuff. We already could ask for some data. Let's just try that. Books, and maybe get the title, but there is no data in it, right? So we are asking for stuff that we don't have yet, so we don't get any data back. Okay, so in order to put some data in here, we actually and that's why I actually got an error. Let's just fix that. And that again. Still get an error. DemoDB should work actually. Let me do one more check. Should it be get? No, it should be working. It should be working. So I have the book context here. context there. Should work everything. So let's debug, live debugging. Not here. Let's take this instance. Just give me a second. Type that in, get the schema, type in our query, and then we will get the debug errors. Because if you start the server actually in debug, it will tell you what is happening. So we get to 500. We can look at the response, and can see that it cannot get the context actually. Yes, I know. So it's telling us that the DB context actually is missing the correct constructor. It has, I would say, the correct constructor. It's not correct compiled. Okay, but I have a fallback solution. So let's just grab for my working solution. As I said, which actually looks the same. Okay. Run that again. And now it should work. I would guess. Doesn't work. Passbooks title. So let me just grab my query over and then we'll see what is wrong. It's always, when you practice it, it always works out, but in the moment you're doing it live, it's crashing and burning. No. Okay, so let's switch over to my other project, which I have already prepared, and I'll walk you through it. Project. Okay. So run. Project. Aqua. Sorry for that. Now it's building. Okay. This should now work. Okay, so it really is broken, and I don't know why. Okay, I'll walk you through it a bit, and then we'll see, maybe we find the error that my system has. It usually works, but maybe I'm too tired to see it. Okay, so basically what we did is we built some queries out. And here we see the more advanced version of the query. It's enough actually to inject the DB context here and then return just some data. And what we can actually do to improve that is actually put in some filtering. So we could just annotate another middleware that basically is built in Hot Chocolate and allows us to rewrite the GraphQL queries that come into native SQL via entity framework, and also do some sorting on top of it. If we look at our schema, which I hope we get, then we can see, if we look at the books resolver, that we have some proper filter logic here. Like I could see that my filter allows for and or operations. I can drill into the IDs, into the fields, do nested searches on that. So if I actually went here to my books resolver now, I could drill into the where, look, for instance, for books that are written by a certain author. And the certain author should have a name. Maybe the name should contain maybe an M, and then we would be able to actually fetch that. Let me just try one more time. I cannot believe that this is broken. It makes me kind of sad. Such a cool demo. Yeah, it's really broken. Entity framework. It is really a shame. Does DB have books? It does. And you can see here, the good thing is on my error here that you can see that it really translated this query into proper SQL. So you can see I asked for the authors and stuff, and it transferred it really into the name. No such table books. Do you know? Let's try that. Let's get rid of the table and just next time I'm be using Mongo. So just I'm rerunning the migration, and actually in order to rerun that properly, we need to kind of change the DB context. This guy here. Data. Demo. Copy. Data. Books context. Yeah, I don't think we get that running today. So for the migrations, I need constructorless. Here, this one, and then it's protected. Right. Okay, this is now a last-ditch effort to get this demo running. I also have a blog about this, but okay, so we call it books. I'm so sorry for that. Come on. Yes, that's okay. Now it's migrating and we're getting a database finally. So now we need a constructor here. This guy has to go out because we are pooling this DB context. .NET run. Okay, let's see. Yay! It works. Okay, sorry guys. So now let's walk you through again. We have 15 more minutes left. Let's have a look at how this actually works. Damn it. Okay, we have no data in here, so we can query, but we don't have data. So I already built some mutations. Let's go to the mutation type here. A mutation is like a query type, a simple class that we just call mutation. And the mutation also has resolvers. And these mutation resolvers actually are executed serially because they perform side effects on your system. There's a very important aspect in GraphQL. Only the top level fields of a mutation are considered mutations. Everything beneath that is already a query on your on the changed state of the server. That is why we get an input here, which is called add author input, which represents the raw data the user provides. And we are mapping that onto our author object. Then we're adding it to the DB context. We are saving our changes here. And then we are returning our author payload with the changed state, in this case, the author object. Okay, so let's try a mutation out. So in GraphQL, a mutation starts with the keyword mutation. And this part up here is called actually an operation. So we can give it a name like add author. And then we call the mutation that we want, which is called, in this case, add author. And then we provide the data, which in this case is just the name. Let's add myself as an author. I'm not a book writer, but still. And then we can maybe reselect the author. And from the author that we reselect, we just want the ID. Let's do that. We write that in. Do debugger? No. Today is not my happy day. Never had that. Let's see if that. No. Yeah, it's really not good today. Yeah, it shouldn't be actually. There. Okay, I know what it is. Okay, there is in macOS, if you push Option and space, it actually produces a symbol that is not readable, that is not parsable, and messes up every JSON and GraphQL you have. Okay, I added the author here. Now let's add a book. So we get some data in there so we can explore how that actually works along. So we're adding again some data here through our input. Something about GraphQL. And then we add the author ID, like 1. And we reselect something from the book, like the ID again, to check and update maybe our client store. We fire that, we get the book ID back. So now we have some data in here. Now we can use some query for the data, and I can already see that there is something wrong here. So let's just write it new. And for instance, we are asking, like we did before for the books, we are querying here for the books that are written by an author, and the author's name should contain maybe an M. Just play it safe. And then we want to fetch the book title and the author's name. And then we already saw it's translating that to proper SQL. We get our data back. and it works. So we can give our user a lot of filtering capabilities here and let you really bind GraphQL to your entity framework context or to your business logic, depends on which way you're going. So this is basically the data integration part. Let's just have a look how that works. What I annotated there, these attributes that you saw in the code. Let me just go back and have a look at that. These queries that these attributes here, like filtering, sorting, use the B context, these are all middlewares. And these middlewares allow me to alter the execution pipeline of a field. And it basically allows me to, in this case, to alter the queryable and change it so that that it produces some other SQL than before. Like in this instance, paging middleware yields always to the next one until the end, where the resolver produces some data, in this case the queryable, and then we return and apply sorting, filtering, projections, and paging. At the end, the GraphQL server produces the result. Okay, we have 9 minutes left, so let's look at subscriptions with GraphQL. And for subscriptions, we actually need to introduce a new type, and the type is called subscription. And in this case, the subscription type looks very simple because I only have to create a resolver that represents an event on my system. And in this case, every time a book is released or published, I want to raise an event. And the event is just returning a book. So every time a book is released, I get a real-time event over this book. And in order to, the payload for my event shall be the book itself. In real implementations, it might be an int or representing the book that we would load with the data loader or stuff like that. But in this demo, we just use a book. So we annotate this argument actually with an event message and then return the book. In order to tell the system that this is a subscription, we basically say this is a subscribe resolver, and the topic of this subscribe resolver shall be this method name here, because we have a very static event in this case. The next thing is we need something to trigger this event. So we go back to our mutation and basically insert there the topic event sender. This is the abstraction of the hot chocolate event system, the pub subsystem that sits beneath that. Okay, and after we have written everything to the database, we will send to that pub subsystem a message. And this is our topic. As I said, we use a method name at the moment as topic, and we just send in the book. And then basically the subscription is triggered, and if somebody's subscribed to that, he or she gets the data. In order to set this all up, we have to go to our startup CS and then add, in this case, an in-memory subscription. We also support Redis and also register the subscription type here. Okay. Then let's go back here. So that means every time I actually write a book, add a book here, I will get an event raised. For this, I need 2 banana cake pops. So I'll take this one. Let's refresh that. Okay, should get the events. And now I can just say, I want a subscription, which starts with subscription. And then I subscribe to the event that we just declared. And from the event, every time a book is released, I want the title. And I also want the author and the author's name. And then I can fire the subscription up. And what happens is actually nothing. We just get this donut here going on. And if we now execute, we can see the data is coming in real time and we could change it, and then can see every time we do something, we get a new event. So this was GraphQL subscriptions. Sorry guys that I messed this up so much. Usually it works out quite well, but this time it really crashed and burned. As a conclusion is, with GraphQL you can iterate faster. And that means front end and back end can do much more work, because the backend developers basically can create a schema that represents the domain model for your business case or for your business, and the front-end developer can just pick and choose and fetch data from that as they need that. It takes away the complexity from data fetching, because you just describe those REST requests, those GraphQL requests, and send them to the backend over HTTP, and you get just the data back in the same structure that you requested. And that makes it super easy to consume GraphQL. I can recommend a book, which is Production Ready GraphQL from Marc-André. He works at GitHub and has a lot of experience about schema design. And if you start a bigger GraphQL project, it's a good book to go to and start learning about GraphQL. Our project is open source. You can head over to chillicream.com, or you can also go to github/chillicream/chocolate to check out the latest version. We have a Slack channel. If you need help or want to get started with this, head over to our Slack channel and we get you started with GraphQL. Again, sorry for the demo. And if you have questions, then please ask. I saw again a message here. Let me read. I missed it on the SQL logs. Under the hood, is the SQL query doing a select stern or a select star, or just the fields you ask for? It depends. So in this example, I didn't use projections, but we also have a projections middleware. Actually, the blog I looked up from myself. Here is a blog on DevTO. And this uses projection in this case, and it would also just select what you asked for. Let me see it. Okay, it's a bit longer, but you can see the selections attribute, and this will actually then cause the requests to be exactly rewritten to SQL requests. You can read this blog post, but somewhere, yeah, you can see the SQL is where it really writes not a select star, but actual fields that you requested. But selections, projections in GraphQL are actually, I rarely do them, because there are more efficient ways to fetch data, like data loaders, which actually batch then the requests, but would fetch everything. But in a graph, it's highly possible that you select entities multiple times, and with batch data loaders, you can reuse those entities. If you have, there's another question. Let me just walk you through. Great talk, thanks. How does Banana Cake Pop compare with other tools like GraphQL? So Banana Cake Pop is still in preview, also coming out at the end of October. It's much richer, can fetch much larger schemas. Also, we support things like defer, and Banana Cake Pop supports things like defer. You can save documents. You cannot do that with a GraphQL, so you can save up your documents. We will also, when it's released, allow you to sync the documents with GitHub and other sources, so you can store them somewhere. Then there is another question. How does Hot Chocolate compare with other .NET servers like GraphQL.net? It's very simple. Hot Chocolate is the fastest GraphQL server on the .NET platform, uses 8 times less memory than GraphQL.net, for instance, and also supports more features. Like I think they are not even thinking about defer. We are actually the first GraphQL server overall that released defer from the new draft spec of GraphQL. So if you want to have the latest GraphQL features, that is hot chocolate. And also, yeah, check out our project. It has so much more integrations into backend systems. If I have a data source that aren't in a database, can I tie them into GraphQL by implementing an interface? If I have a data source, yes, you can. You can. So you can mix data together. We also, Hot Chocolate also supports schema stitching. That means you can rewrite data from everywhere. So, and that is really very simple. Like this is a local GraphQL server now at the moment. But I could just go in here and say, add remote, I don't have the stitching package, but as soon as you put the stitching package in, you can just say add remote schema, and then you can fetch another GraphQL schema from somewhere else and merge it with your local GraphQL schema. You can do that also with OData, also only in the new version. Is Banana Cake Pop long polling when it executes the subscription? No, it's not your long polling. Banana Cake Pop uses WebSockets and the GraphQL subscription specification. But it is possible to do it also over SignalR. There are other questions. How do you prevent a GraphQL endpoint from becoming a monolith? Actually, you want GraphQL to become a monolith. So, or actually, you want the schema to become a monolith. And just as a comparison, Facebook has the biggest or largest GraphQL server out there with over 10,000 types, 300,000 fields, and it's an absolute monolith. But with the GraphQL servers that are out there, including Hot Chocolate, you can do things like schema stitching, break your GraphQL server in various domain services, and then have a single gateway that automatically stitches them together to one GraphQL endpoint. But the schema, you want to have one source of truth, but you can split it over many services. So there are techniques. Schema stitching. It's if you go to the Chili Cream website, you can check that out. There's schema stitching, and there's an introduction how you can merge schemas together.